Hi, students. We're back again. We're going to continue where we left off yesterday. We started talking about section 8.1, electron dot diagrams. I believe I stayed off on the third slide, which is this one. And we started talking about valence electrons. Well, I'm going to go over this slide one more time. We started yesterday's topic talking about how this drawing that you see, this picture on the left, is a diagram of a football play for a particular team, and it doesn't say what team, right? But the reason why it's coming up is because this diagram shows where each player is going to stand, what direction they're going to move when the ball gets snapped. You got to remember, electron dot diagrams, they show the valence electrons around an element symbol. And it's going to give us an indication or an idea as to how this element will react when it comes in close proximity to another element. So you got to remember that valence electrons are occupied or are found in the highest occupied principal energy level. That's that outer energy level, the last one that's at the very outside of our the last energy level, where maybe it's full, maybe it's partially full, maybe it's half full. But though that is where you're going to find it, the highest or outer energy level. Okay? You have to remember that valence electrons have very important roles and dictates a lot of chemical properties for elements. Okay? They are responsible for the way an element reacts. Okay? So valence electrons, a big responsibility that they have are chemical properties of elements. Okay? They are responsible for chemical properties. So, and then the last thing, one way to determine how many valence electrons an atom has or an element is to use the electron configuration. Okay? So that's the three most important things from this slide. First, where are electrons located? In the outer energy level. Second, why are they important? Because they're responsible for chemical properties of elements. And then what's one way that we can determine the number of valence electrons? With electron configuration. Okay? Remember those three things because it's going to come up right now. Hold up. All right, students. 5th period. You need to complete the sentences below. Valence electrons can be found blank, comma, and are responsible for an atom's blank, period. One way to determine the number of valence electrons is, and I forgot two, is to use blank, period. All right, so try it out. Let's see how many of these blanks we can answer without having to go back to the last slide. All right, so let's start this out. Valence electrons can be found. Where can we find valence electrons, guys? Where can we find valence electrons? Anybody remember what I said from the last slide? Irvin, Mario, Alexia, where did we say that we can find valence electrons? Anybody out there? Do you need some options? Okay, I can give you some options. I'm going to give you some option. Option 1. So remember, electrons are always in energy levels, right? So I'm going to give you some options. Will I find valence electrons in the first energy level? Or, that's option 1. Or will I find valence electrons in the middle energy levels? Or option 3, will I find valence electrons in the outer highest energy level? What do you think? 1, 2, or 3? Where am I going to find these valence electrons? In the inner energy levels, or the first energy level, the middle energy levels, or the outer energy levels? Pick one. What do you think? What do you think? Mario, Alexia, Irvin, what do you think? Inner energy levels, or the first energy level, the middle energy levels, or the outer energy levels? What do you think? What do you think, guys? Help me out, please. What do you think, Alexia? Take a guess. Mario, take a guess. What do you think? Can you hear me? Can anybody hear me? Let's see. No responses on Pear Deck. What are you guys doing? Are you listening? Hello?
Yes, miss. What is it?
Where can I find valence electrons? In the first energy level, in the middle energy level, or in the outer energy levels? Pick one.
Outer.
Outer, right.
I say outer.
Yes, it's always that outer energy level. So the answer for the first blank would be the highest or the outer energy level. Okay, let's start now. Do the second part. And are responsible for an atom's what? What are valence electrons responsible for? Do they have no response? I'm sorry? Can you repeat that, Mario? What are they responsible for? Do we need to go back to the last slide? What are they responsible for? Come on, help me out. What are valence electrons responsible for? They do have negative charges, but what are they responsible?
Properties of elements.
Yes, chemical properties of elements. Okay, last part. One way to determine the number, of valence electrons is to use what? What's one way to determine how many valence electrons? According to this.
From the electron configuration.
There it is, from the electron configuration. Okay. Any questions on that one? Okay, now let's talk about group number and valence electrons, okay? In each case, valence electrons are those in the second principal energy level. As one proceeds left to right across a period, the number of valence electrons increases by 1. In the S block, group 1 elements have 1 valence electrons, while group 2 elements have 2 valence electrons, okay? I'm going to go to Jamboard real quick, so come back to Google Meet so you can see. Can everybody see Jamboard? Can you guys see Jamboard? Yeah, Alexia, can you see Jamboard? I just want to double check.
I can see it, yes.
Okay, just making sure. Okay, so the first thing that we're going to talk about is the group, and we're talking about group number 1. Everybody who I just circled, everybody is part of group 1, right? We got hydrogen, lithium, sodium, right? Hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Every single element in that group will have one valence electron, okay? All right, group 1. Group 2 is next. Everybody who's part of this group will have 2 valence electrons. Beryllium, magnesium, calcium, strontium, barium, and radium. Everybody, it doesn't matter who I pick. I can pick strontium, 2 electrons. Beryllium, 2 electrons. Calcium, 2 electrons. If they are in that group, they have 2 electrons. Okay? Now let's talk about the next one. In P block, the number of valence electrons is equal to the group number minus 10. Group 13, 3 valence electrons. Group 14, 4 valence electrons. Up through group 18 with 8 valence electrons. The 8 valence electrons is known to have a full outer S and P sublevel and gives the noble gases that special stability that everybody wants. Okay, so let's go back to Jamboard. And I'm talking about first group 13 right here. Group 13. Every single element in this group is going to have 3 valence electrons. Just take off the 1, right? That's how you're going to remember it. Take off the 1 and leave the number that's there. 3 valence electrons. If I'm talking about group 14, everybody here will have how many? 4 valence electrons. Group 15, 5 valence electrons. Group 16, 6 valence electrons. Group 17, 7 valence electrons. And group 18, 8 valence electrons. Do you see what I mean? How just all you have to do is just take off the 1. Okay? So I'm going to ask you some questions. Let me ask you some questions. Come on. Super slow, my computer. Okay. All right. Now I'm going to circle some elements and I'm going to ask you how many valence electrons for that element. Okay? Get ready. Yalexia, I'm talking to you first. Yalexia, how many does this element sulfur have? What do you think, Yalexia? How many valence electrons for S for sulfur?
This might answer your question. Sulfur has
Alexa, off. Not 16. Remember, take off the 1.
6.
Very good. Irvin, how many will this guy have? Rubidium. What's the group number, Irvin?
1.
Yes, sir. Mario, what about this element? Aluminum. Take off the 1 from the group number. Mario, 3. Very good. Yeah, Alexia, how about this one right here? Germanium. Group 14. How many valence electrons? Take off the 1.
2.
What's the group number, mujer?
4. 4 is 4. It's a 6.
It's a 4. It's group 14. Take off. Remember, the group numbers is what you see at the top, guys. I know it's really, really small. Maybe I should zoom in. Hold on. Let me zoom in. Can I? Okay, there. It's a little bit bigger. Okay. Look at the group number. The group number tells you how many there are. Look at these numbers at the top, okay? So for germanium, he's in group 14. Take off the 1. How many? 4. What about for bromine? Group 17. How many valence electrons for bromine?
7.
What about for magnesium? Group 2.
2.
Yeah, Alexia, what about for nitrogen? Group 15. Take off the 1 from the group number. 15. It's in group 15 over here. Nitrogen. This one. Let me get a different color. Nitrogen right here. N. Group 15. Okay, hold on. Let me make things easier for you. Hold on. Let me try something. Maybe this will help you. Okay. If I have, hold on. If I have, okay. So for group 1, it's going to be 1. For group 2, it's going to be 2. For group 13, it's going to be 3, 14, 4, 15, 5, 6, 7, 8. Okay, Alexia? Now, let me ask you. How many does silicon have? How many does calcium have? How many does selenium have? It's all about the numbers. And you can see the numbers. The numbers are here. If you don't see it, I would get a periodic table and put the numbers that you see here. That way you don't forget, okay? Very good. Everybody seems like they got it. Anybody else need a practice? Mario, do you need a practice? Or did you get it?
I got it.
You got it? Okay, how many for this guy? Li. How many for lithium? Li. Mario.
3.
What does it say at the top in red?
1.
Okay, how many for this guy? As, arsenic.
5.
What about chlorine?
7.
What about xenon?
8.
Yes, sir. Very good. Okay, now I know that you got it. Just double checking. Okay, very good, guys. Okay. Now I want you check this out. I'm gonna ask you a question. Pick 3 elements and tell me how many valence electrons. And you're only talking about the groups that we identified. Okay, pick 3 elements from all the ones that we picked from here. From group 1 and group 2, and then group 13 all the way to 18. Don't include these. I'm not talking about these. Everybody else, okay? Pick 3 elements. At least pick 2. Pick at least 2 if you can. Okay? pick at least 2 and make sure they're not from the same group. No cheating, no same group. They have to be in different groups. I'm not talking about these. These are all out. These we can't predict them the way we can predict the other elements, okay? All right. All right, ready. Okay, let me see your Pear Deck answers. Where? Oh, I don't see them. Oh, you're going to put them in here? Put them in the chat then. Let me see them in the chat. Go, Irvin. Put yours first. Put the symbol of the element and then how many. So, for example, I'm going to pick one just so that you can see what I mean. Lithium has 2. That's how I want you to do it. Show me your 2, Irvin. Show me your 2, Alexia, and show me your 2 elements, Mario. And you can just put them in the group in the Google Meet chat. You don't have to put them on Pear Deck. I mean, I would like them on Pear Deck, but let's just use the chat for now. Go, Irvin. Let me see yours. What 2 elements did you pick? They better be from different groups. What about you, Alexia? Where are yours? Show me. Okay, boron. It has 3, right? Very good. Over here, boron. 3 valence electrons. Very good. Pick one more. Pick one more. Carbon, right here. Definitely 4. Nitrogen, 5. Okay. Alexia, Mario, pick 2. 2 elements. Mario and Alexia, pick 2 elements, please. Still waiting, guys. I don't see any.
Sulfur.
Pick it. Write it down. Tell me the numbers, just like Irvin did in the chat. Let me see it, Mario. If I can't see it, it don't count. Pick different ones, guys. Pick different ones. Different elements. There's a whole list here of other elements. Pick them. Pick different ones. I don't want the same elements. Silicon. Silicon 6. Oh, no. I'm sorry. Silicon 4. Very good. I was looking at. Okay. Oxygen 6. Very good. Sulfur 6. Okay. Alexia, what's your second one? Oh, carbon and oxygen. Okay. Carbon, they had already picked it. Alexia, pick another one. Thank you. All right. Perfect. Those look really good, guys. Look really, really good. Great job. Okay, now we're going to draw what's known as the electron dot diagram. When examining chemical bonding, it is necessary to keep track of the valence electrons of each atom. Electron dot diagrams are diagrams in which the valence electrons of an atom are shown as dots distributed around the element symbol. Beryllium atom with 2 valence electrons would have the electron dot diagram below. So you're going to draw the symbol of the element, but now instead of writing the number, you're going to draw dots for that number, okay? And you're always going to spread them out. One on top, one on the right, one on bottom, and one on the left. And then if you have more, you double up. And you're going to double up the way you see it in this picture, okay? Since electrons repel each other, the dots for a given atom are distributed evenly around the symbol before they are paired. The table below shows the electron dot diagrams for the entire second period. Electron dot diagrams would be the same for every element in that group. So if you're talking about lithium, the one that I picked earlier, you're going to draw the symbol with 1 dot. If you are in group 2, if you are talking a group 2 element, any element in that group, you're going to draw the symbol with 2 dots, the way you see it for beryllium. For group 13, you're going to draw 3 dots around the symbol. For group 14, 4 dots, 15, 5 dots, 16, 6, 17, 7, and then group 18, 8. All right, let me show you what I mean by that. All right, so if I'm talking about rubidium, if I'm talking about the element rubidium, okay? If I'm talking about the element rubidium, I'm going to write the symbol for rubidium with 1 dot. Why? Because he's in group 1. He only has 1 valence electron. All right. If I want to pick another one, if I want to pick, nobody picks selenium, right? If I want to pick selenium Se, how many dots do I need to draw? Well, what's the group number? 6. So 1 on top, 1 on bottom, on the side, and then I double up. You see what I mean by that? Do I need to do more examples, or do you understand what I'm talking about? One more example, or are you ready to practice on your own? So this one you cannot do on the Google Meet chat. You're going to have to come into Pear Deck, okay? You're going to have to come into Pear Deck. You already know your number. You already know your symbol. You just need to draw it. Join me in Pear Deck for just this one question if you are not in there. And I only need you to draw one element. You don't have to draw both of them or 3 of them. Just pick one element, write the symbol, and then draw the dots. Go. Irvin, Yalexia, Mario, draw one symbol with the dots around it for one of the elements that you picked earlier. So Irvin should either draw boron, carbon, or nitrogen. Yalexia will either draw oxygen or neon. Mario, you're going to draw either... Alexa off. Oy. Mario is going to draw either sulfur or silicon. All right. Go. I'm waiting for you guys to start drawing, and you can draw it here on the side. Come on, guys. Get into Pear Deck. You cannot do this in the Google Meet chat. I need you to get into Pear Deck and draw it there. Hurry, please. We're running out of time. Jump into Pear Deck. Irvin, are you drawing? I don't see you drawing. I don't see anybody drawing. Look at that. No responses. I'm waiting. Oh, there we go. We got somebody. Whoa, why'd you... Okay. Which one are you doing? Who picked chlorine? Carbon. Chlorine or carbon? Who's this? Chlorine. I don't remember you guys picking chlorine as one of your elements from earlier. I want you to use one of the answers that you had earlier. The one from Pear Deck question 2. Irvin picked boron, carbon, and nitrogen. Mario picked silicon and sulfur. Yalexia picked oxygen and neon. I want you to use that information. Use one of those that you already have. Carbon. How many dots are you going to draw? What's your valence electrons? Wasn't your valence electrons 4? Draw 4 dots. Separate them, Irvin. No. One on top of the symbol, one below the symbol, and then the left and the right. Better. Very good, sir. Very good, sir.
I suck at it, miss.
It's okay. Yalexia, where's yours? Yalexia. Mario, where's yours, Mario? Mario. Why are you not in Pear Deck drawing? Marco did his. Mario, talking to Mario. Talking to Ms. Alexia. Alexa off. I guess Irvin's the only one that's going to get extra credit.
Sorry, I'm not sure.
Okay, then.
I can do another one, miss.
No, it's okay. That's good. We don't have enough time. We're running out of time. So let's just watch the video. I know you can do another one, but we're running out of time. So let's watch the video and let's finish up the lecture.
Hey, welcome back. Today we're going to talk about electron dot formula, also known as the Lewis dot formula. Chemical bonding depends mostly on the number of electrons in the highest or outermost energy level. This level is called the valence energy level. The electrons in the outermost energy level are referred to valence electrons. Chemists have devised a shorthand system to indicate the number of valence electrons in the valence energy level. This is called the electron dot formula. So if you look at a periodic table, you see these group numbers up at the top of the periodic table. So hydrogen has one valence electron. Magnesium here has two valence electrons. And then we skip all of the numbers from 3 to 12. And then you see that they just start at 3, 4, 5, 6, 7, and 8. So carbon has 4 valence electrons, not 14. The most important thing when doing the electron dot formula is the order of the dots. So I have some examples here. First, we'll start with lithium. If we go back to the periodic table, we see that lithium is in group 1, so it has 1 valence electron. So that means you have 1 dot around your atomic symbol. So that is your electron dot representation for the lithium atom. Our next example is calcium. If you go to calcium on the periodic table, you see that it has 2 valence electrons. You go back here and you go 1, 2. You always want to make sure you're going around your atomic symbol like this. Our next example is nitrogen. So we see that nitrogen has 5 valence electrons. Nitrogen. So you go 1, 2, 3, 4, and then you start going around again. 5. Our last example is iodine. So you find iodine on the periodic table, and you see that it has 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. Hopefully that helped you out with your electron dot representations.
Thank you. All right, let's finish up the lecture. In summary, electron dot diagrams show the valence electrons for an atom. Second point, the dot diagrams are the same for each element in the representative element group. And then you have your review questions. What are valence electrons primarily responsible for? 2, calcium would have the same electron dot structure as which element pictured in the table? 3, what is the symbol for an element that would have the same electron dot structure as carbon? And 4, would you expect the group 18 elements to have the same electron dot diagram as neon? Any questions on